Hello everyone, welcome to Mathematics Meal, a beautiful program and lovely program designed for all beautiful and handsome people. In this program we use simplified method in dissecting mathematics so that students can understand mathematics easily. Today on Mathematics Meal we are looking at part 2 of sorts. That's what we are going to consider. In our first video we looked at the meaning of sort and also the types of sort, where we considered binomial sort and monomial sort. So today we want to look at another aspect of sort, and that is basic laws in sort. That's what we are going to consider in this part 2 of sort, basic laws in sort. Just relax. You can take a glass of water, just as I want to take my own water. You can just take your own so that you relax, calm down as we begin this wonderful journey. Water is good. That's H2O. It's very good. Don't mind me, I don't have glass here. The most important thing is that I have taken water. All right, let's begin this beautiful aspect of what? Of sort. We want to look at the basic laws. The basic laws in sort. Basic laws in sort. So, basic laws in sort. Basic laws in sort. Okay? What are these basic laws in sort? They are preliminary laws that we must note so that we don't make mistake while trying to simplify expressions and terms that contain what? Sorts or radicals. So let's look at these basic laws in this way. If x and y are whole numbers, if x and y are whole numbers, then the following rules will exist. The following rules will exist. 1. Square root of x plus square root of y is not equal to square root of x plus y. Number 2. Square root of x minus square root of y is not equal to square root of x minus y. Number 3. Square root of x times square root of y is the same thing as square root of x times y, which is actually square root of xy. Then 4. Square root of x divided by square root of y is the same thing as square root of x divided by square root of y, which is something as square root of x over y. So when we have whole numbers, let's say that x and y are whole numbers. They are not negative. Already we know that negative of a square root of a negative number will not exist. If you press it in your calculator, you'll be having mass error. Except when you now begin to talk about complex numbers in mathematics, then you can now convert the square root of a negative number to be in complex plane. But we are not dealing with complex numbers now. So square root of a negative number will not exist. So if we have whole numbers, and these whole numbers, of course, they are not 0, x and y are not 0, then these rules are possible for whole numbers. And we are going to prove them using real numbers, so that we will not use a complex way of proving it. To prove it, we'll just use numbers, real numbers, to prove them, so that you can actually see that these rules are correct. Okay. Square root of x plus square root of y is not the same thing as square root of x plus y. In other words, finding the square roots before adding the numbers is not the same thing as adding the numbers before finding the word square root. Very important. Finding the square root before subtracting, that's this square root of x minus square root of y. This means, this side means find square root of x, use it to subtract square root of y. So find square root of x, find square root of y, and subtract. That's what this statement means. But here, it means subtract them and then find the square root of the difference. Here, find square root of x, find square root of y, add them. But this means add them and then find square root of what? Find square root of x plus y. So, if we find the square root of x and find the square root of y before adding, it will not give us the same result as adding them before finding the what? The square root. So if we carry out the square root operation first before addition, the result will be different from adding before carrying out the square root operation. The same thing is applicable to the subtraction. Then in multiplication and division, if we multiply the square root and finding square root after multiplication, will have the same result. In other words, if I find square root of x and then find square root of y and multiply them, it will give me the same thing as multiplying them first before finding the word square root. That's what we're saying. The same thing here in division. If you find the square root of x, find the square root of what? Of y. Then the result we are going to have will be the same as dividing them before finding the what? Finding the square root. So we are going to use numbers. Let's say that I'll use so many numbers because I just want to produce whole numbers. Let's say I have 9 and 16. Let's say I have x is equal to 9 and y is equal to 16. These rules are applicable to all numbers, all whole numbers. So if you can decide on your own to test other numbers apart from the numbers I'm going to use. So you can test other numbers. So if x is 9 and y is 16, it means that square root of x plus square root of y, we have said, is not the same thing as square root of x plus what? Y. So if x is 9 and y is 16, it means I can replace x using 9 and then 16. It will not give us the same thing as square root of 9 plus 16. Here we are trying to find square root, and add. Here we want to add before finding the what? The square root. So square root of 9 is 3, square root of 16 is 4. It will not give you the same thing as square root of 9 plus 16 is what? 25. Okay, 3 plus 4 will give me 7. What is square root of 25? 5. So you see 7 is not equal to what? 5. So finding the square root before addition will not give us the same result as adding before finding the what? Finding the square root. It will not give us the same result. We can see it clearly here. Okay, let's look at the second one. Let's say that x is 25 and y is, let's say, 16, and we want to carry out subtraction now. Square root of x minus square root of y is not the same thing as square root of x minus y. Okay, let's prove that using these numbers. Square root of 25 minus square root of 16 cannot give us the same thing as square root of 25 minus 16. Okay, now let's find square root of 25. What is square root of 25? 5 minus square root of 16, 4. It is not the same thing as square root of 25 minus 16 will give us what? 9. We have 9. 5 minus this is 1. It's not the same thing as what? 3. Because square root of 9 is 3. So you see that it will not give you the same thing. Wow. Take a glass of water. Let's continue. Yeah. Water is important. Yeah. Very, very important. So we have been able to show this and this. Then let's look at division and multiplication. First, multiplication. Let's see whether it's possible. Let's use the former number. The first set of numbers we use. X is 16 and y is what? 9. So let's see. Square root of x times square root of y. We say it's something as square root of x times y. Okay? Let's impute this. Square root of 16 times square root of 9 is the same thing as square root of 16 times 9. Okay? What is square root of 16? Square root of 16 is 4. What's square root of 9? Square root of 9 is 3. Okay? What is 16 times 9? 16 times 9 will give us 144. Okay? 4 times 3 will give us what? 12. And square root of 144 will give us 12. Do you see? They are equal. They are the same thing. They are the same thing. Very much the same. So you see it? We have proved this. So one more to go. And what is that one? Division. Division. So these laws are very necessary so that when you are trying to carry out other operations, by the time we begin simplification of what? Of sort. Maybe one we now have square root of 5 plus square root of 5. So that you will not make mistake of trying to do a square root of 5 plus square root of 5, and something will start pushing you and push you, and then you will just write square root of 5 plus 5. That would be dangerous. Very dangerous. It means that you did not understand these basic what? Laws. That's why we have to look at these basic laws first before we move into other aspects of simplification of what? Of sort. Very important. Okay? So let's look at the last part. Supposing x is 100 and y is 25. Let's deal with this quickly. So it means that square root of x divided by square root of y, we have said ultimately is something as square root of x over y, which is what we saw here. Okay? Okay, so let's look at this. If we substitute x as 100 divided by square root of 25 is equal to square root of what? 100 divided by 25. Now what's square root of 100? That's 10 divided by square root of 5. 25 is what? 5. It's same thing as saying 25 divided. You know, we are finding square root first before division. Here we want to divide before finding square root. So when 25 divide 100, we are going to have square root of what? 4. Beautiful. So when 5 divides 10, 10 divided by 5 will give me what? 2. And square root of 4 is what? Is 2. Beautiful. Beautiful. So you now see that these rules are valid. Yeah, they are valid rules in mathematics. Very valid. They are valid rules. Alright, that's all on part 2 of sort. I believe that you have mastered these rules. You can go on and try with other numbers. Just choose any number, any whole number. Use any whole number and test these rules. And then you discover that they are actually true. Thank you for following us till this point. Remember, a meal a day is very necessary if you want to grow healthy mathematically, if you want to grow healthy in physics, and if you want to grow healthy in other sciences. You need to take a meal a day. And where can you get this meal that will keep you healthy? In mathematics, in physics, in chemistry and biology. Where you will get it is at Mathematics Meal Part 1 or Mathematics Meal 1 on YouTube. Or you go to our Facebook page, Mathematics and Science Meal. There you will find meals that will keep you healthy in mathematics and in sciences. Thank you for following us. We are going to come back, and when we come back, we shall be looking at basic form of sort. Don't miss it. Thank you, and God bless you. I love you.